Checkpoint. Queremos agradecerle de verdad de corazón a Checkpoint el haber colaborado con nosotros. Es un patrocinador nuevo que directamente ha venido como patrocinador oro. Y para nosotros es una demostración de confianza como no se puede hacer de ninguna otra manera. Entonces estamos encantados de esto. And Jonathan will handle the speech, so go ahead and make your own presentation, and thank you so much.
Do I need to turn it on? Do you hear me?
Yeah.
Okay, great. Buenas tardes. And voy a hablar con inglés. Sí, está bien. Okay, so I used up most of my Spanish. And from Windows Bootkits, we're going to talk a little bit about mobile security. Okay, so before we start, let me just quickly introduce myself. My name is Jonathan. I'm from Tel Aviv, Israel. Currently leading the data science team in Checkpoint, mainly responsible for investigating mobile malwares. And my formal education is a BSc and MSc in electrical engineering, although most of my practical experience has been in the last decade has been in software, and more specifically in the cyberspace domain. And I worked at Lacoon before Checkpoint, which was an Israeli-based startup dealing with mobile security. It was acquired by Checkpoint almost a year ago, and I've been enjoying Checkpoint ever since. Before that, I was working for the military, for the Israeli military. So the names here, just want to mention the major contributors to this research that was conducted in our research group and was led by two of our lead researchers, Avi Bashan and Daniel Brody. That credit is due. Okay, so we're gonna talk today about CERTIFI-GATE, which is a very interesting vulnerability that we found in Android system. And probably a lot of you that uses Android also in here has this vulnerability on their devices, and it's not closed, so it's very interesting, and we're gonna see why. So a little bit about motivation. What we basically like to do is to take the thread domain, the mobile thread domain, and try to group it and cluster it based on different behaviors. A very interesting specific group of threats is, of course, the MRATs, which are the mobile remote access tools. Basically, the mobile trojans. There are a lot of commercial ones, like Dendroid, Hacking Team, and Mobile Stealth, Mspire, just some of the names, but there's a lot more of those sorts, even unknown mobile remote access Trojans. And we try to take this group and take a look of what identifies, what characterizes this group of applications. So most of them has access to all of your sensitive information, your call log, your location, your emails. They send most of this data to a remote CNC server, a command and control server. And in order to gain access to this information, most of them doesn't have the permission, so they use an exploit. But there is another interesting group of applications that share a lot of the properties of an MRAT, except of the exploit usage, which means that they are granted those permissions in advance. And this is the group we're going to focus here today. So this group is the MRST tools. The MRST tools are the mobile remote support tools. So what are they? Basically, remote access to your phone, right? Like remote access to any PC. They're used by IT departments, by mobile carriers, by device manufacturers, so they can remotely access your phone, configure your settings, your network setting, maybe do a little debugging. Those are probably the leading brands today in the market. Okay, so how does these remote support tools work? For those of you who are not familiar too much with the Android system, let's do a quick overview. Basically, Android is a modern OS. It uses okay, so each application runs with its own unique identifier within a sort of isolated sandbox from the other applications. Each application must declare in its Android manifest, which is a file included in the application that the developer used to declare the permissions that it would like to use. Then, when you install an application, you see this screen, as most of you Android users have already seen it at least once, where the application declares which permission it wishes to use. And the approach is, of course, take it or leave it. You can either install the application and grant all those permissions, or choose not to install the application. However, there are some sort of permission that cannot be used by any application. Some of those permissions are read buffer frame and inject event, for example, that allows an application to access and read the screen buffer. Of course, that as a developer, even if I wish to use those permissions, Android wouldn't let me, even if the user would like to give me the permission. I cannot use such permission. A regular application cannot use such permission. And this is obvious. Why? Because this breaks the principle of isolation, because once I can read the buffer, it doesn't matter how secure your email client is, I can still read your emails. So this can only be used by third-party applications. Cannot be used, I'm sorry, by third-party applications. So who can use it? Well, basically, every application that comes built pre-installed with the ROM, or it is signed by the OEM, which is the manufacturer, like LG, Samsung, and so on. Okay, so far. So let's take a look at the remote support tool. Okay, so as we said before, the remote support tool allows you to access remotely remote access to your device. In order to do so, but one of the things that it needs is, if you want to debug your device remotely, is to see the screen. So you do have those privileged permissions, but we said before that an application cannot be granted those permissions unless it comes pre-built with a ROM or it is signed by one of the OEMs. So what did the support tool vendors did? They teamed up with the OEM, LG, Samsung, and many more, and the OEMs agreed to sign those applications in favor of the support tools. Okay, so how exactly does the architecture of the support tools look? Because looking back at this, you don't want every time that you compile a new version of your application to send it to the OEM to re-sign it again. So what did they do? They splitted the application into two parts. The first part is the background part. It's the plugin. it's invisible by the viewer, by the user. It is signed by the OEM, LG, Samsung, Huawei, etc. It has those privileged permissions, which mean it can read your screen, it can inject input events, and it is an exported service. Who uses this? The second part of the remote support tools, and most of the tools are built like in this fashion. And this part doesn't have any privilege or unique permission. It has regular application permissions. It is signed by the support tool vendor. And it has, of course, network connections, so it can send the information back to whoever controls the device. And it has a user interface. So, of course, the two parts need to talk. So the main application asks for the plugin, asks the plugin to take a screen capture, for instance. The plugin has those permissions. It takes a screen capture, and then sends it back to the main applications. Of course, here, some of you may already notice the problem here. And I haven't mentioned the communications is an interprocess, a regular IPC interprocess communication in Android using Binder, which is the Android IPC mechanism. And so the problem here lies in the communication between the main application and the plugin. Of course, the plugin needs to authenticate the main application and verify that it is indeed the main application of the specific vendor it belongs to. So none of the other applications can exploit this mechanism and use the plugin for their own benefits. So, and this is, of course, a problem because whoever of you know, this is up to the vendor now to authenticate, and each vendor may reinvent the authentication mechanism. And that's, of course, a big place to look for security vulnerabilities. So a quick recap. What do we know? The plugin is, of course, signed by the OEM. It can be obtained from Google Play or come pre-installed on your mobile phone. It is an exported service using the Binder IPC, and it is its responsibility to verify the main application. Okay, so here comes the interesting part. What did we find? Okay, so just a minute. Don't want to trip. Also to keep you in some suspense. Okay, so what did we find? Teamviewer, one of the leading brands. Clicker. Uh-oh. Maybe wiggle a bit with the battery. No. I think this works. For some reason. Switch off. No, it's okay. Switched on. Okay, it's back on. Okay, so sorry about that. So Teamviewer, one of the leading brands of the remote supporters, it is supported by most of the OEMs, LG, HTC, Lenovo, Samsung. Basically, this is a picture from Google Play. Basically, almost all the OEMs signed the Teamviewer plugin and supports Teamviewer. Okay, so let's check out Teamviewer authentication mechanism. I'll let you take a look for a couple of seconds and see if you can spot here something interesting. Okay, so of course the interesting part is this one. This is the way Teamviewer plugin authenticates Teamviewer main application. What it does, it preloads a fixed serial number of the certificate and then verified that the certificate serial number matches the hard-coded hard-coded serial number. Okay, so who can set a certificate serial number? So a serial number can be assigned by the certificate authority. Unfortunately for them, Android supports who signs applications. So Android supports self-signed certificate. Okay, so this is a big issue. It means basically that I can issue my own certificate, set the serial number. They don't test the issuer, the key, nothing. Only the serial number. So I can issue my own certificate with this serial number, set the serial number, and I get granted access to the plugin and can ask the plugin request and get responses. So let's take a look at a short demonstration that we prepared. Okay, so what do we see here? What we have prepared for you and recorded. So here we have a demo web server that we started on our PC. And this is a mirroring of the Android device to the PC, so you can see both of them on the same screen. And now what we're going to do is we're going to install our application, which is our demo application, which doesn't use any permission at all. It's a fake application, fake flashlight application. And it has our own certificate with a specific desired serial number. And now we can capture the screen. So what you see here is our application sending to the web server the screen captured from the device, which is pretty cool that we were able to do that without any permission, which means that this also works. Basically, now, once we've installed it, we can see all of your input. The demo application that we prepared take a screen capture every few seconds and send it back to our demo server. So this is pretty cool, how without permissions we were able to see everything that's going on the device. And we can see, we can see anything that you type as well. We can simulate and inject events. Basically, everything a remote support tool can do. Okay. So, thanks. Okay, so this is pretty cool, and you're probably thinking, okay, so maybe Teamviewer didn't do the authentication right, but probably most of the other vendors did it okay, and we're safe. So we took another look and checked out one of the other vendors, one of the other popular vendors, our support, and also, also supported by most of the popular OEMs, and it comes pre-installed on LG devices. And this is what we found. And it cannot be uninstalled. So on the devices that it come pre-installed. Okay. So what did we find? Okay, so our support didn't just check a hard-coded number. They did a bit more. What they did is they calculated the hash of the certificate that is signed on the main application. This is, of course, again, this is the plugin checking the authentication of the main application, right? So they took the signature of the certificate and calculated the hash code. And then compare it to a couple of hard-coded values, probably their own, the hash code of their own certificates. Okay, so the problem here is, if you saw it already, that they use Java hashcode. So Java hashcode is basically a function that helps you, take an object and randomly assign a value to put them in a hash map or something like that. It is in no means a cryptographic hash code. What it basically does is it takes the signature, the certificate, as a byte stream, multiply each byte by 31, and then adds the next byte. And then return the results as a 32-bit integer. This is, of course, this is already a major problem, because nothing that short can be cryptographically secured. You can easily, on your own computer, brute force it. But not even that. We, our mathematicians, were able to reverse this function. Unlike SHA-1 or MD5, this is not a cryptographic hash code, so it's reversible. And we were able to reverse it in such a manner that we were able to derive the certificate up to 1 bit of non-deterministic. So this is definitely reversible. This is definitely not secure. And a weak authentication mechanism as well. So, to recap, the attacker can connect to a pre-installed plugin. And then it can use the application that doesn't require any permission, and then it bypasses the Android security restriction and all of the Android secure conventions very, very easily. It can gain ability not only to permission that he didn't declare, just like regular permission, like accessing the internet or the calendar or SMS or stuff like that that a regular application should declare but didn't. It can also access privilege permissions and gain access to all of your device resources. So let's take a look at the timeline. This was discovered in April, and most of the vendors got notified a month or 2 months later. And then they started preparing hot fixes and patching everything. And today, most, if not all, of the plugins are already fixed and re-uploaded to the Google Play Store. And okay, so we found a vulnerability, we found a security hack, we patched it, and everything is okay, right? Right? Okay, so let's investigate some more. So we wrote a nice application that you can download from Google Play, which is a scanner that lets you know if your device is also vulnerable to these sorts of exploits. So the scanner can check if a plugin can be installed on your device, or is it already installed on your device. And we let people download it and check it out. So we got a great response, more than 100K downloads. And almost a third of them agree to upload their statistics back to us so we can investigate. And you can read a lot more about it in the blog if you're interested. The link is on the bottom. And what did we find? Okay, so basically we found that 15% of the devices that send us back the scans had one of the plugins already pre-installed on their devices. And almost two out of 3 devices are vulnerable to this kind of attack, which means they still doesn't have the plugin installed, but their OEM is signed on this plugin, which means that the plugin can, in the future, be installed on their device and then be exploited. And as you can see, LG is one of the most vulnerable as it comes with the plugin pre-installed on their devices. But one of the more interesting things that we found, and this was really exciting to find something that you dig up in the lab to find in the wild, is that we found 3 devices that contain an active exploitation, which means not only that they had the plugin installed, they had a third-party app that took advantage of the plugin just as we saw before. So who is this mysterious app, this rogue app? So this app is a recordable activator that had found in Google Play, had, I think, 500,000 downloads. And what it does, it claims it can capture screen without rooting the device. And how does it do that? Well, exactly as we show. They took advantage of the Teamviewer plugin. Once you install this application, it downloads the Teamviewer plugin, installs it on your device, and then uses it to take screen capture. Of course, it was already removed from Google Play, as it violates Teamviewer properties. But the main thing to notice here is that even after Teamviewer removed their malfunction plugin, they removed it from the store, and today in the store there is only the fixed plugin, the problem still exists. Why? Because the weak authentication plugin could have been and has been pre-downloaded from Google Play and stored on third-party servers. And now what the application does is just download the plugin from its own server, and of course it can be installed on the device because it's pre-signed by the OEM, and there is actually nothing anybody can do about it. So the conclusion is that even that the vulnerability was found and declared and fixed, still there is not much thing to do about it, and it still continues to live in the wild because the signed plugin already exists and can be reinstalled on those devices. And the main issue that we want to focus here is that the chain of trust has been broken. So this is the main problem here. Google trusts the OEM to sign their own applications. And the OEM, in turn, trusts the vendors, the remote support tool vendors. And you have a chain of trust established. And if one link in this chain isn't strong enough, the whole security mechanism isn't worth that much. And this is, of course, not limited to remote support tools that we investigated here. This could also happen on any other application on any other third-party application that is signed by the OEMs. And there are more examples of this sort. And this concept of breaking the chain of trust isn't even limited to Android. It also happens in iOS. If you know famous attacks on iOS, both Xcode Ghost and eSpectre, in one case, they took advantage of the developer, and in the other case, the eSpectre case, the exploit used enterprise certificate, which are privileged permission certificate in iOS to gain privileged permissions. So this concept is pretty wide and exists both in Android and in iOS and so on. So to conclude, we have hundreds of millions of Android devices that are vulnerable. Actually, I found that my own personal device was also vulnerable to this attack. And so what is left to do is to basically keep monitoring and checking for the vulnerability, checking for vulnerable applications. Threat detection can be a bit hard because this could be escalated horizontally, which means any other third party can now take advantage of this exploit. And to mitigate this risk, all we have left to do is to alert the user to remove any bad plugins and track patching and update progress and keep our devices up to date. Okay, that's it for today. If we have time, I'll talk a bit about, I have a bonus later. Do you have time? Okay, so just a bonus slides. Presented, and then we'll come back to the questions, is another angle about breaking the chain of trust. So this one we did for another vendor that we're not going to disclose here. And okay, now we're not talking about exploiting the communication between the main application and the plugin. We're talking about abusing the main application itself. So not replacing it, but using it. So one thing that we found is that one of the vendors uses SMS to configure it's like a CNC, but it's not a CNC. It's like the domains that it talks to and gets its command from. So the problem is, again, it has to be perfectly secured, otherwise you can hijack it. And what we found is that we can send our own SMS, and the domain is not it's not sanitized with the SMS that you send, so you can add an additional slash and then inject your own domain and then take control of the main application. So this is pretty nice, and this is just another angle about how we can exploit the chain of trust, and this is a further link in the chain of trust that we exploited, and we can use it to our advantage and to take control of the remote support tool. Okay, so yeah, as we said, we send an SMS with our own configuration, hijack it, and insert our own domain, and then we gain control on the remote access tool. Okay, so back to, that's it. Thank you, and if you have additional questions.
Oh my God. I will move to Windows Mobile again.
What?
Questions? Preguntas? Preguntas? Micrófono. Espera.
Here.
Yeah.
I'm wondering, what about if we force the new plugins to check a certificate requisition list, so that if something is wrong, we can force to reveal a new certificate, and those will not work?
I'm not sure I understood. You're talking about changing the way the plugin verified the main application certificate?
Yeah. So that if we
Yeah, of
force-
course. You can do that. You can fix the plugin, and the vendors like our support and Teamviewer already fixed their plugins. The problem is that the old plugins, the plugins with the vulnerability, still exist, and you can still, and someone can still install the old plugin on your device. So even after they fixed it, it still exists.
More questions?
Yes.
Hi.
Hi.
If I install an EOS AP custom ROM, will I protect my device?
Probably, yeah. Yeah, I think so.
Okay, thank you.
Maybe it depends on the OEM
Yeah, it
applications you
depends
can
on the
deploy.
OEM, but if he installs like vanilla Android, then it will probably be
Cyanogen
okay.
or whatever.
Yeah.
¿Más preguntas? ¿Más preguntas? Una aquí. Jonathan.
Hi, thanks for your talk.
Hi.
And I just wanted to ask, what capabilities do we have with this kind of exploitation? Like, do you only get access to what the remote access tools have, or do you have access to hijacking maybe the kernel or something like that?
Okay, so not hijacking the kernels. You don't have.
I mean, code injection and like access to actually.
No. You don't get root permissions or stuff like that, but you do get those special permissions that allow you to, as we said, set up, change the setting on the phone, inject events, and read the screen buffer, and all the set of the normal privilege, but not root access.
Okay, so if there was a way to get root access through user input or like some commands or something, you could technically do it, right?
Yeah, if the plugin were granted root access, then by coincidence, we would get the root access as well, yeah.
Hi.
Hi.
Hello. Here.
Hi.
Have you studied this with something like Chromecast, for example? Would it work?
It is interesting. We haven't tried it. So our research group is focused on mobile, but I believe it's worth the try, probably.
Yeah, because if I've understood correctly, your
Mhm.
Android device wouldn't let you share your screen unless you install a plugin. Is this correct? For that OEM.
Yeah.
But for example, I use Chromecast in my phone, but
Mhm.
I don't need to install any other plugin. I only need to install the Chromecast application.
Yeah, but Chromecast is signed by Google, right?
Yes, that is what I am asking. I don't need the special application, I just need the...
No, what you do need is an application that is signed by either Google or one of the OEM vendors. The problem is that when you develop your own application, you are not granted with those permissions, right? And even if you ask for them, it still won't help you. You need to get your application signed by either Google or one of the OEMs.
Okay, so Chromecast would act as the plugin itself.
No, Chromecast doesn't need a plugin. Chromecast
Yeah,
is
that's
already
what I
signed.
implied.
Yeah.
Okay, thank you very much.
You're welcome.
One final question, right there.
Have you done this kind of research over mobile antiviruses?
Yeah. Can you repeat it, please?
Yeah. Have you done this kind of research for mobile antiviruses apart from remote support tools?
I didn't understand the question.
If you did the research on antiviruses or security tools on mobile devices.
Have we done the research? Well, not yet. Maybe this year.
This is a good
Yeah,
question.
because those are tools that also get a lot of permissions, and it could be something interesting.
Yeah, it is.
My next question is, have you tested this in DLNA services, VLC players, and these kind of applications that may retrieve plugins and, you know, I see this is an open field.
Yeah, probably is. Yeah, we haven't checked it yet.
Thank you so much, Jonathan.
You're welcome. Enjoy lunch. Thank you.